So we're going to make little squares inside the big square. And we're just going to take that command, paste it there, indent it nicely. And now I have one loop nested inside the other. And if I execute, you can actually see it. Whoa, that's not quite what I meant to do. Oh, actually it is, right? That's kind of neat.
Yeah, that is.
So you can see the kind of fun little patterns and things you can end up drawing. Just depends on the length of the square you end up drawing inside, how it looks.
Exactly.
So I had some fun with that, because I forgot I'd drawn a little square. Originally it was a 100-size square.
Yeah.
So you can have some fun playing around with this. Now I am going to take 1 minute just to sort of illustrate. I'm going to put a breakpoint here, and I'm going to execute my code. And the reason I'm going to do this is because I want you to sort of see, here I am going in. Oh, frame not, that's getting, oh, it doesn't, it's a little messed up here. Stack frame was not found loading. That's a neat message. Execute, please. Okay, it's...
Maybe stop.
Yeah, I think it's, I don't think it likes me debugging when I'm in the middle of drawing things. I think that's throwing it off. But it will literally, it'll execute this code once, enter this loop, execute this loop 1, 2, 3, 4 times. Then go back here, execute this a second time, enter this loop, execute 1, 2, 3, 4 times. Go back up to the top, execute this a third time, execute the inside loop 1, 2, 3, 4 times. Go back up here, it'll be the fourth time, execute it, then execute this loop 1, 2, 3, 4 times. So that's actually the way the code flows when it's actually executing. All right, now one of the things we did look at yesterday was the power of using variables inside your code. And one of the great things about using a variable, instead of repeating the same value over and over in your code, is it means if you need to change a value later, it'll be faster. So what I've done here is in my code, I've created a variable called number of sides to my object. Because I was telling you, you can calculate the angle to draw a perfect shape by just saying the angle you need is 360 degrees divided by number of sides you want the shape to have.
Yep.
So by doing this, I can just say, hey, you know what? If I want a 6-sided object, execute the loop 6 times. But instead of putting the number 6, I'm saying just read the number of sides on the object from my variable. And then when I tell it how many degrees I want it to turn, I say it's 360 degrees divided by number of sides.
Yep.
Now what's neat about this is if I go and do this in my code, number sides equals, and I'll start off with 4. So initially it's going to be exactly the same square that I was drawing before, number sides. And I'm changing the angle is going to be 360 divided by number of sides. And if you do the math, 360 divided by 4 is 90. So it should still be a 90-degree turn.
Carry the 1. Yes.
Got the math? My math's good?
Yep.
You've had your coffee this morning. Well done, Christopher. And now when I run, we get exactly the same drawing we did before. So, you know, initially you look at it and go, this is just a little more code. Why would you bother doing it this way? And I'm actually going to make this a little bigger because I think the other objects will look nicer. So I'm just going to redraw it with a bigger outside square. So it looks a little more like this. So you can see the little square is being drawn inside the big square. But now, if I want to make it a pentagon, I just change that to a 5. One change, and suddenly I have a whole new object. Oh, did I forget to change something
you
somewhere?
forgot one little update.
Oh.
Yeah, you'll notice you've got
there
the
we
second
go.
one. Yeah, that also needs
I
to
told
be
it the inside loop needs to
Although,
execute.
you know, having the string of pentagons was actually kind of
It's kind
cool.
of fun. Yeah, it's fun. This is what I was after. There we go. So you can really have a lot of fun playing around with this, and you can see how now this sort of becomes a, you know, what if I make this 20? Who knows, right? What do I end up with then?
And, you know, yeah, a lot of people are asking about circles, and so kind of there you go, and loops would be a great way to do that. And, you know, one of the things that a couple of people pointed out is, hey, you know what? My kids are going to love this.
Oh, yeah.
And there is a reason why logo is, and turtle, well, you know.
This is turtle.
Yeah, this is turtle. Well, logo, turtle. Well,
yeah.
Anyway, but there's a big reason why this is used with kids and also with adults is because of the fact that it's fun, it's cute, it's something to play with. And when you're learning, if you're having fun, you're going to learn it that much better.
And you'll practice.
Exactly.
Because you're going to want to play with it. You're going to want to experiment. I love this. It's like spirograph playing with this thing.
Ooh, good reference.
Yeah. So anyway, you can see the objects drawing there. So it really is quite fun to play around with it. So that's why I love playing with the nested loops.
Yeah.
But notice how I said by using a variable, I can now change one line of code and completely change the output. And that's the power of using variables in your code. So we just talked about that. All right. So we've also demonstrated that as well. Now, one of the things I haven't done yet in my code is I've never actually looked at that variable steps. I never actually used it anywhere in my code. I had to declare it when it's part of a syntax. I have to have this variable steps in my code, but I was never using it. The fact is, that is a variable, and it will actually have a value every time the code executes. The first time you go through the loop, it will have a value of 0. The second time you go through the loop, it will have a value of 1. The third time you go through the loop, it'll have a value of 2. The last time you go through the loop, it'll have a value of 3. The way this works is when steps reaches the value here, it exits the loop. So you can actually reference that variable inside your loop. And there will be times when you want to count. And using a for loop is a great way to count to a particular number. And you can use that to do math and all kinds of neat little things in terms of problem solving. So just remember, in programming, we always count starting from 0. That's really important to remember. It takes a little getting used to. You'll forget it occasionally. Your code won't do what you want. And then you do something. I've actually done this to debug code before when I couldn't figure out what was going on. Sometimes I'd actually print the value of step on the screen, even though I didn't need it. I just printed it on the screen so I could see what was happening. That's an old coder's trick, to just print a value on the screen while your code is executing so you can see what's going on. We do have a debugger, but sometimes I still fall back on that. All right, so if we go back to the slides, what if you want to count from 1? I mean, there are business situations where sometimes you need to count from 1, not from 0. In that case, you are actually allowed in syntax of Python, instead of just specifying a range of 4, you can specify a start and end. So you can say start counting from 1. So the first time it executes the loop, the value will be 1. The second time it'll be a value of 2. The third time it's going to be a value of 3, and now it's done.
So it's up to. Right,
because when the value equals the range, it stops executing. So the thing to remember is if I write a loop that says run from 1 to 4, it only executes 3 times. So that's the thing you got to remember about that, is when it never reaches the higher number. It usually counts from 0. So a range of 4 would execute 4 times. But when you say, start from 1, then it only executes 3 times. As soon as it reaches a value of 4, it says, I've reached 4. That's the maximum. Time to get out.
And I'm done.
And I'm done, exactly. So that's important to be aware of. Now, there's another neat thing you can do in terms of syntax on for loops, and that is specifying a step or a skip, amount to skip by. What this is going to do is the first time it executes the loop, it's going to be a value of 1, because that's our start value we specified here. The second time, it's actually going to have a value of 3, because we specified this skip step of 2. So basically it said jump by 2. The third time it executes, it'll have a value of 5 because we told it to jump by 2. The next time, value of 7 because again, we told it to jump by 2. The next time it'll have a value of 9 because it jumps by 2. When it reaches a value of 11, it's going to say, wait a second, 11, that's up around, that's higher than 10. If it reaches 10 or 11, it would never execute with a value of 10 or 11 because we've said get out when you reach to 10. And so this one actually only ends up executing 5 times. But it's interesting when you start playing with steps, and if you specify minimums and maximums, you have to be very careful. You might accidentally write a loop that executes 1 too few times or 1 too many times. I'm drawing it out on the screen. I'm literally writing out the numbers. I do that on paper when I'm trying to figure out my loops. I have sat there with a piece of paper beside me going, okay, wait a second. The first time it does a loop, it's going to be a 1, and the second time it's going to be a 3, and I literally write it out on paper so that I can count, and then I go back and count and go, wait, I needed it to execute 6 times. I need to change the value. So that is a perfectly valid practice. Write it out on paper, and then you can see what your code's going to do. If you're lucky, you'll get it right the first time, but quite often it's a common coding mistake to just get it off by 1. Test, test, test. So you think it's running 4 times, run it, make sure it's running 4 times.
Exactly.
So if we go back to the slides, and now this is a really cool, I love this trick in Python. This is really interesting. Now, however, I want to point out it's a little different syntax here. There's a word missing in this command. The word range is missing. I've written the for loop, but I didn't say the word range. And the other thing is, my brackets changed. I was using the rounded parentheses before. Now I have square braces or square brackets. So 2 big changes in syntax here to be aware of. And I'm specifying a series of values. What I'm doing now is I'm actually telling my for loop exactly what values to use when it runs through the loop. So I can actually tell the for loop, the first time you go through the loop, use this value. Second time you go through the loop, use this value. Third time you go through the loop, use this value.
So it's sort of like what other languages might call a for each loop.
Yes.
So if you were in C# or VB, like a for each, because what you're saying is the first time through it's going to be 1, the second time through it's going to be 2, or you could of course have changed the numbers.
Those numbers could be 72, 15, 7, and 8.
16. Don't forget 16, the number of the day.
Sure. So if we go back to the slide, the first time it goes for the loop, it takes the first value in the list, and the value of steps is going to be 1. Second time through the loop, it takes the second value in the list. That's going to return it, so steps will be 2.
Yep.
Third time through the list takes the third value. That would return a 3.
Yep.
Now, and instead, this number here could be 44. That's fine. And if it was 44, it would then, steps would be 44. I happen to enter 4. And the last time through the loop, it is 5. Now, in this case, yes, it will execute for that last value because you're telling execute once for each value I'm providing. But just, I guarantee you, the first time you do this, you're going to accidentally type the word range, or you're going to use the wrong brackets, and you're going to get syntax errors. So just look it up when you need to, but it's a really cool feature and very useful.
Yep.
So that's the output we get. Now, what I really like about this is the way you can play with things like, said so viz that reminder. You don't have to use numbers.
No.
No, you can say any value at all. You want the loop to execute, and here's the value to put into that variable steps. So we go back to the slide again. This time, I said my loop is going to have a value of red. So the first time the code executes, the value will be red. The second time the code executes, the value of steps will be blue. The third time the loop executes, it will have a value of green. And the fourth time it executes, the value of the variable steps will be black. So what I'm doing is I'm drawing an object, I'm changing the pen color each time through, so I end up with a multicolor square.
Awesome. So a couple of things that I'd love to mention here. Real quick, number one on your slide, and I love the fact that you've been consistent with steps, but it's definitely worth calling out here that you could have used whatever name it is that you wanted.
Sure.
So you could have maybe used color instead.
Oh, I like that.
Yeah.
Okay, hang on. Maybe we can do the little eraser thing here. I don't want to let me think.
Yeah, it won't let you erase the
hang on. We'll have to.
Yeah, you'd have to bail out of the slide there.
Okay, hang on. No, we'll get a pen here, and we're just going to scribble that out.
There you go. I love it.
We're going to write color. But I'm a Canadian, so I'm spelling it with a U.
And then put that
scribble
down
that there,
as well.
and this is now going to be C-O. That's a really good point. That's a much better name for the variable in this scenario, because in this time when I'm going through the loop, the variable I'm setting is really holding a color. So
Exactly.
That's a much better name.
Yeah. Now, the other thing that I'd like to point out real quickly, because there's been a few questions about this in the chat window, about putting together that list of numbers that you had. And if you were using 1 through 5, could you have done like 1.5, or could you have done 1-5?
Oh, no, unfortunately, Python doesn't support that syntax. You do have to, if you want to count from 1 to 5, use the syntax we had earlier. If we go back to my slide, if you want to go from 1 to 5, use the in-range syntax.
Exactly. Yep. Yeah, the only catch would be with range, of course, is if you wanted to display the number 5, you'd have to say 1,
to
6.
That's right.
Exactly, because always remember that it's going to be up to, but not including that number. So you would have to use 1, 6 if you wanted that 1 to 5 range.
Yeah.
Yep.
Awesome. Great. Some great questions coming up there. So just to sort of show that sort of neat little example, if I'm just going to comment out this code using the great Control-K, Control-C command to turn that into comments, and I'm just going to write a little for color in red, green, blue, and black. And in that loop, oops, I forgot my colon. And then I'm simply going to tell Turtle to change the color to the color value that I read from the loop. And then I'm going to tell Turtle to draw a line, move forward 100. And then I'm going to ask Turtle to turn, oh, what the heck, let's go left, just because we can. Because I can turn left. No Zoolander references? I was waiting for that.
Oh, no, I was going to say jump to the left.
Okay, yeah, that would work too. All right, so I execute my code, and the first time through, the color should be red, so we should see a red line, then a green line, then a blue line, then a black line, if I did this correctly. Fingers crossed. There we go.
There it is, just like that.
So, really said you can have a lot of fun with this. Okay. You can actually mix up different data types when you are specifying explicit values. So in this case, I'm saying, red, blue, green, black, and 8. But there is a little problem with this. If I execute this code, the problem I'm going to have is when I say change the color of the pen to 8, Turtle's going to be really confused and go, what color is 8? So 8 is not a valid color, and so this would actually crash my code. So you do need to be very careful if you're trying to mix data types. It's not generally recommended. It's valid code, but it might crash your code because maybe when you use the variable later, it doesn't work. If you actually go back to the code, let me look at the slide here. You can see it is possible. I was doing a print statement, it would work, but not when I'm trying to change a color. So your challenge, now that you've had a chance to play around with this.
Should you choose to accept it?
I want you to have Turtle draw an octagon. Right? So there's just a reminder here of how to calculate the angle for an octagon. As an extra bonus or extra credit, try to rewrite it so the user can type in how many sides they want the object to have and draw whatever they ask.
And one little thing that's worth highlighting there, especially for people who weren't around yesterday, that they could use input to obviously collect that piece of information, but the catch is that input's only going to send in a string, so you need to convert that. So
you're going to need to convert that string into a number before you try to count how many sides the object has. So you're going to have to, if you get to the extra credit, you're going to have to deal with data type conversions as well.
Yep, exactly.
All right.
Yeah.
And there's even double extra credit, which is add a nested loop inside to make the little one inside the big one.
Exactly. Yep.
So have some fun with that. And we'll be back in 10 minutes.
Yeah, that's basically it. Yeah, we'll be back in 10 minutes, and the next module will be looping when we don't know the number of times that we're going to loop.
Yeah, so we're going to look at some different types of loops for different scenarios.
Yeah.
See you shortly.
We'll see you in 10. All right, well, welcome back. This is still Introduction to Programming using Python. That's still Susan Ibach. I'm still Christopher Harrison. And in the prior module, we took a look at how to do for loops.
That's right, yeah. So we were starting to look at how you can write code that will repeat efficiently.
Yeah, exactly. Now, the for loop is fantastic, and I have to admit, and we talked a lot about this yesterday, that there's oftentimes multiple ways to solve the exact same problem, and when it comes to having to do something X number of times, I trend towards, and this is true across all programming languages, some form of a for or a for each, depending on the language, some form of a for or a for each. But the catch with using for or for each, depending on your language of choice, is that you have to have a pretty set number of items right from the get-go. And a lot of times, you don't actually know that. So you might be looking to go through a loop of records where something could change while you're looping through it, or maybe while your code is executing, maybe you're going through a queue. And something might happen where I go, all right, well, I know this item is going to take me a little bit longer to process, so I'm just going to throw that back down to the bottom, or something like that. So it could be that I don't know right up front the number of times that I need to do something, or the number of times that I'm about to do something could change while my code executes.
Yeah, so, or just from one execution to the next.
Exactly. Yeah, so, we still need to have kind of those same actions, the kind of real world or analogy of, pour a cup of coffee for each guest. By the way, pour my cup of coffee first, please.
Okay.
Yes.
Sure.
Yes. Thank you. Washing all of the dishes, putting together each name card. You have to handle all of those different things, kind of those analogies. But when we get into programming, I might be looping through a file. I might be looping through a number of entries in memory.
I'd say a lot of times in coding, we'll have things like somebody gives us a file and we want to read all the values in a file, or we do have a database table and we want to read all the people from a particular country entry from a database, but we don't know how many records we're going to be getting back from a database before we start.
Exactly.
So, yeah, there's a lot of situations where we know we're going to have to do something over and over, but we just don't know how many times.
Exactly. And sometimes, we can calculate it, but again, not always, So if it's a scenario like this where, we know that we've got 20 guests, then we could just go in and explicitly state, okay, fine, it's 20 guests. Or it could be a scenario where maybe we've got this in a list, and a couple of people asked about that earlier. We'll be talking about lists.
We will get into lists. Yeah.
But I could go in and I could ask the list, well, how many items are inside of you? And I could throw that into there. Or we could actually just simply say form in list, but now I'm sort of stealing your thunder.
Yeah. Come on, I'm going to get to that. Don't steal my next slide.
Right, you're right. Okay, I'm sorry. But in any event, I can calculate that number of times, but that's not always going to be the case. And this is where while loops come into play. That the concept of a while loop is we're going to do something, perform an operation while something is true. So what I'm going to do here is sort of just jump straight to the syntax. And this is a perfect example of where a while loop is going to shine. So let's start with, of course, keyword while.
Yep.
And just as a real quick refresher, I'm just going to do this right away. You'll notice my colon, and then you'll also notice the tab in right there. So kind of, again, that same thing with an if statement or a for loop or everything. We've got the colon, we've got the tab. This is what's going to be executing, and that's just simply what says, hey, go there. All right, cool. So again, we've seen all of that. Now let's explain the concept of a while loop, and I think the easiest way to explain it is to do it in English. A while loop means do something while a condition is true, while something is true. So if we go back to our code here, what we're going to be saying is while answer, whatever answer is, we'll talk about what answer is here in just a moment, while it's not for. So this could be something like while file is not empty, while all candidates are not processed, or again, some conditions. So as long as something is true, we're going to stay inside of that loop and we're going to kind of keep doing what we're doing. Now, the next part that I want you to notice here is that unlike that range, where again we had that set of defined numbers, what you're going to notice with this example is we're asking the user for input. And we're asking the user to input the answer to a question. So what is 2 plus 2? I have no idea how many times it's going to take somebody to enter in the correct value. It could be that they do it the first time. It could be that they do it the 51st time. And again, the next time that the program runs, I still don't know. And the next time, I still don't know.
Right.
So there's no way that I could say, well, we're just going to loop 5 times, or we're going to loop 20 times. I don't know how long it's going to take them to get it right. So this is where a while loop shines, because now I can say, well, look, as long as they keep getting this answer wrong, we're going to stay here until they get it right.
Yes.
That's what my while loop is all about. All right.
So let's keep going as long as I have to.
Exactly.
While loops are great that way.
Yeah, and that's really it. So give me 1 second here. I'm going to do 2 things behind the scenes. One is going to be to get out of my slide, and the other one is to launch Zoom It, which, by the way, if you haven't already seen or heard, what we're using to draw on our screens and zoom in is a great little tool called Zoom It. I know that we've got a lot of students. What was the percentage? Did you see the poll?
30% of the people here are students.
Yeah.
Yep.
So one of the things that I remember in college and in university was having to do different presentations to kind of show off, hey, this is what I learned. This is a great little tool to play with to do presentations. And again, it's a free tool. It's a great way to draw attention to the spots on the screen that you want. Okay. In any event, let's start doing this here. And I'm just going to go in and say answer equals 0. Now, a couple of things that are worth highlighting. Number one is you're going to notice that I'm going to initialize that variable right away. And the reason for that is because I'm going to use this on my while loop. So if I'm going to use this somewhere, it needs to be initialized in advance. So I'm initializing that up at the top. The second thing that I want you to notice here is that I've initialized it to a string, and I'm going to be using strings. Now, you might be looking at that and you might be thinking, well, gosh, Christopher, that seems a little bit odd because you're asking somebody a math question. That you're asking them, answer equals input, and what is 2 plus 2? And you are right that I am asking them a math question. But if you remember back to yesterday, input gives me back a string. So the fact that I'm asking them a math question is sort of irrelevant. It's sort of secondary here. That the fact that it's a math question is not what's key. What's key here is the fact that we're doing an input, which again is going to give us back a string, and that's what we want to do here.
Okay.
Okay. So now,
rather than converting everything to numbers and comparing, I mean, you could have converted the answer into a number and said if the answer is not equal to a number 4, but in this case, it's a bit of overkill.
Exactly. So here, you know what we could also do? We could just do this real quick. What is the answer to the ultimate question of life, the universe, and everything? Boy, how about that? I barely had enough space to fit that onto the screen.
Yeah, well done.
Thank you. All right, so now let's go in and run this. It will then ask me what's the answer to the ultimate question of life, the universe, and everything. And as we all know, that's of course 42. Yeah. And I'll hit enter, and it says, congratulations, you are right. Let me kind of run that on the bad side. So we'll say 16, which is the number of the day. Hit enter, nope. 54, nope. 67, nope. 42. And now it says, congratulations,
there you go.
You're right.
And so now we exit this loop.
Exactly. Yeah, so it was waiting for the answer to be 42. So as long as it wasn't, it was just going to stay inside of that loop. And that's a perfect example of where to use that type of a loop, because I had no idea up front how many times it was going to take for whoever it was to get that answer correct. Okay. Let's see. I want that. That's sort of weird.
Going back to your slides?
I am, but PowerPoint is beating me up here. There we go. Okay.
All right, you're good.
I'm having PowerPoint issues. All right. So let's talk this through. What will this code do? And I'm talking a bit slowly here to kind of wait for the bit of a lag that we've got here for our fine viewers to go in and kind of contribute inside the chat window.
Right. So I can see you're using Turtle again.
Yeah. Okay. So we're using Turtle again.
You've got a counter, a variable called counter.
A variable called counter.
And you're setting that to start off at 0. So I know counter is 0 when the program starts.
Yep. Okay.
Then you have a while loop. That says while counter is less than 4. And I know right now when I'm starting the program, counter is only equal to 0. So 0 is definitely less than 4, so I'm going to enter the loop.
Okay, that's good math. Yep.
Okay. And then, so I'm going to enter the loop, and it's going to move my little line forward 100 and turn right. So this is me trying to like draw lines on the screen again. So I move forward 100 and I turn a corner.
Yep.
And then I'm saying counter equals counter plus 1. Now that's my way of saying add 1 to the counter.
Yep.
So now counter is equal to 1. So now, I guess when I get to the end of a loop, it's going to go back to that while statement again. And 1 is still less than 4.
Yep.
So I'll go through, draw another line, add another counter, it'll be 2. I'll go up, 2 is still less than 4. I'll draw another line, I'll turn right, I'll add a number to, it'll be, counter will now be 3. I'll go back up, 3 is less than 4, it'll draw a last line. And then the next time I go through, counter will be equal to 4. And when 4 is not less than 4, and then it should exit the loop. So 4 times?
Okay, so it's going to do the loop 4 times. What's it going to wind up drawing out?
Square.
It's going to wind up drawing out a square. So it's going to go forward 100. It's going to turn right 90, forward 100, right 90, forward 100, right 90, forward 100. That was actually a little off of a square on my drawing. Not bad by hand, though. But in any event, it's going to draw out that square. So we've actually already seen this. We just saw this with a for loop rather than with a while loop. Now, I do want to just pivot off of this real quickly here, just to highlight that little counter equals counter plus one. That there was a couple of people in the chat window that had mentioned the concept of variables in Python and kind of mentioned, oh, you don't have to declare them. And the answer to that is no, you can just start using them. So I also want to highlight the fact that what we've done is a counter, again, is a bucket. So what you can do is dump that bucket out and put in a new value, but you could use that variable for that update. And I gave the analogy yesterday that, again, if it's a box, if I had 2 slices of bread, that I could take out those 2 slices of bread, put in a couple of slices of ham, some nice good spicy mustard, and then put that back into the box. And what I've now done is I've used what was in there, but I've now updated it. So we've gone from 2 slices of bread to a sandwich. So sort of that same concept